Now, let's talk about energy. What is energy? In books such as the Resnick, that is a classical book for people studying physics, the definition of energy is given in the following way. Energy is the capacity to do some work. And when we look at the word work, what is work? Well, in physics, it is defined as a force that is applied to an object to move it a certain distance. And therefore, energy becomes almost a synonym, meaning almost the same, as a force. A force that is applied to an object in order to move it a certain distance. And to every action, there is a reaction in opposite direction. This is Newton's third law. And this is to do with motion. And that reaction in opposite direction is called friction. So when we want to move something, we got an opposite force that is opposing the movement that we are aiming to do by simply pushing, and that is called friction. And different surfaces have different coefficients of friction. It's not the same to push something on ice, where the friction is almost nil, compared to pushing something on asphalt or on tiles or on a rock. So the material that is used as the base for that object, where it's allowing its mass to be resting on, pretty much conditions something we call the coefficient for friction. When it comes to Newton, he basically described many things, among them behavior of physical objects that he described mathematically. And therefore he became he became the most well-known scientist of his time and even to now. He developed a concept of physics that we still use. It's called classical physics, and even it bears his name, Newtonian physics. And Newtonian physics has to do with this ability of objects to be moved by applying a certain force. And because we talk about a force, there is another force that plays a role on all this, and this is the force of gravity. The force of gravity is an acceleration, and that comes from Newton's first law, where the force is equal to the mass times the acceleration. And you might have heard of this if you have done physics, and if you haven't, well, I'm not going to go into detail, but what I would like to point to you is that we talk about forces because they are synonym. That means they almost mean the same as talking about energy. But energy has many different expressions. We got kinetic energy, potential energy, mechanical energy, thermochemical energy, spiritual energy. We got emotional energy. We got spinning energy. We have 0 point energy, the scalar energy. My goodness, the list seems to go on and on and on and on. The common denominator is the word energy. So what is energy? Is it really a force? Are we looking at something that only moves objects? Well, the answer is no. We need to look into other scientists to explain this. And the first one that comes to mind is Albert Einstein. Albert Einstein lived at the beginning of the 19th century, and it was around 1905, from 1905 to 1916, that he published most of his work. He became really famous for his theory of relativity. However, he was awarded the Nobel Prize in 1921, not for that theory, but his theory on the photoelectric effect. And here we're talking about another type of energy, photonic energy. And what is a photon? Well, a photon is energy that an electron leaves behind when it moves from one shell to another of lesser energy. And again, the word energy comes into place. That is called atomic energy. As you can see, we can go on and on and on talking about this amazing world of energy for practical purposes and for the reason that I'm here sharing with you this knowledge is to share with you the mechanics of how we can be able to use technology through the S-Drive to decode information that is endemic to each one of us. That also uses energy. But we need to look into another part of physics to be able to explain it. And this is more exciting because it's opening new ground, new roads, new ways of looking at things. Not many people believe in this, but believing doesn't matter. Anybody can believe whatever they like. But when you know, there's no reason why you need to believe, because you know it. And this is what is exciting about this. We know what we're talking about, and this is my duty to share it with you. So that I hope that you bear with me a little bit longer so that we can get to the point that I would like to make, and that is that every single work that allows for things to happen the way they do, they have to do with three phenomena that we call the what for, and the why. In other words, we can talk about intention, we can talk about purpose, and we can talk about significance. The intention becomes the what. Purpose becomes the what for, and the why is the significance. So, why do we do what we do? Why do we get up every morning and go to work? Why? The ultimate answer, when you think about this, it's a very beautiful special energy, and that energy is called love. It's simply for love. For love for oneself and for our loved ones, our families, our friends. That's the reason we do everything in the name of love. And the work of God talks about love everywhere. Creation itself is the product of love. Every single thing that works with love works with a particular frequency that is electromagnetic, and it can be measured. And we know exactly what that frequency is. It happens to be 528 hertz. And we are talking about electromagnetic waves. A wave is an expression of energy. And how do waves form? Well, it's when matter stores energy and then releases it in the form of a wave. Let me give you an example, and we need to go back to secondary school because I'm sure that you remember this, because you might have studied something called trigonometry. And if you manage to get to high school, then you might have studied something called analytical geometry, where we studied geometrical figures, such as the sphere, the ellipse, the hyperbola, and the parable, among others. And this places us in a very privileged position, because with that simple knowledge, we can explain a lot. The way nature does it. With the minimum amount, you get the maximum return. It's called efficiency.